Yeah, hold up. That being said, what? It's totally true.
Oh my God.
Hey, last thing. I am looking for that Faja board because I don't know how to say it. So yes. So far, you guys are way in the lead by 8. I'm gonna keep that as a running tally. So like on the other thing to tell you, we are having another math day on Monday. So I'm gonna just keep that number going up. You shut your mouth. I'll count the last 2 days too. Period 3, by the way, was all upset that I didn't count those first 2 days of the semester when you guys had like 19 and 14 people each day. So you're feeling lucky right now. We're doing math on Monday, and then we are going to build on Tuesday and Wednesday.
Oh, sweet. Okay, never mind.
So we're trading, we're having a double math and then a double build. One of the reasons because the weather Tuesday and Wednesday looks to be very nice, and we need to flip those floors and insulate them and put our walls up so that we can stop having rain in our house. Okay. So that means that homework assignment right there, 27 through 30, is due on Monday, plus 32 and 33, right? So 27 through 30, 32, 33, due on Monday. Another math day on Monday. After the weekend. Okay, we are going to talk about some, excuse me, Brussels sprouts. Okay, we're going to talk about, I had Brussels sprouts for lunch. Hey, whoa, you're not doing it right if you don't like them. Here's the deal. No, in my Chipotle mac and cheese with roasted Brussels sprouts.
Would you ruin your mac and cheese?
Come on in. You know what I want to do to you, Kimani? Okay, just because 8 of you didn't do your homework, let's try and if you know, you're going to raise your hand, not your mouth, okay? We are going to do some vocab work right now, but again, if you pay attention to the words that I'm saying, they're really not vocabulary based. The first one I want to talk about is one that we know, so I have this drawing here. The first one, and please write this underneath your warm-up. Sam, I need you in a better spot. Yeah, like right over there or something, so that you can see. Like not on that side. Oh, you can go to that side, but just scoop. Yeah, okay. The first one I am going to talk about are vertical angles. Now, as you write this down, please take note of the fact that angles is spelled G-L-E-S. I am not writing angels. Okay? Angles, L-E-S. Angels, E-L-S. Make sure your L and E are in the right spot because we're not talking spirituality. Right? No angels in this class. Obviously. Okay. So, by a hand, who can tell me a pair, no mouth, by hand, a pair of vertical angles on this drawing, Mitchell?
The 2 lines going vertical.
You will use the letters A through H in your answer.
Oh.
You want to try again? Are you redeeming yourself?
Yes, I want to try again. Never mind.
Maximus.
B and F.
No. Mickey.
A and D.
A and D. Yes.
Oh, never mind. Oh, and then I got this.
We've talked about vertical angles in here. Mitchell's trying to redeem himself.
Wait. F and G.
Beautiful. Any others? Sam.
B and C.
B and C.
Any others?
Stevie.
G.
Wait.
Oh.
Our guys. If I already heard from you, don't raise your hand again. Okay, and then E in 105. Yep. What do we know about vertical angles? Ethan? Yeah, they're vertical from each other. Let's go a step further though. Levi? Same measure, right? There's congruent. They're the same measure. So like E, right? What's the degree measure of E? Boom. 105, because 105, 105. They're vertical angles. We've talked about that one. All right. Next one, we're going to move on to some new ones. Yeah. 55. All right. Please write them down so you have some notes. Well, use your eyes. I understand. I was just joking. All right. By a hand. Corresponding angles. Give me a pair of corresponding angles. If you already answered it, put your hand. Taylor. G and C. That is correct. Corresponding angles. Notice if we ignore this little triangular piece, G and C are in the same spot, right, between those parallel lines. Yeah, Josephine? Yep, E and A, again, they're in the same spot. They're both in that top left corner, Pacific Northwest, of those parallel lines. Okay, A and E. What else do we have? Steve, I already heard from you. Malachi? Yep, nope, sorry. 105 and B is not true. Shayla? B and F. True story. And then, yes, D is corresponding to 105. And what do we notice about corresponding angles?
They're across. They're like in the same spot.
They're congruent. Thanks, Major. Right? D and F, I can also see are going to be congruent. They're going to be the same. Okay, now we're going to spice it up a little bit. I'm sorry, 105 and D. Yeah. Okay, I know. See if we can contain ourselves. I'm beginning, this is bothering me. Here we go. Here we go. I can do it. I believe. Maybe. There we go. Okay. Pro. Next one. We only have 105.
Well, I like that channel A and B.
Alternate interior angles. Not angels. Alternate interior angles. If I've heard from you already, don't answer. Use you know what those words mean? Alternate interior angles. Chris? Yes. C and F are alternate interior angles. Alternate meaning opposite sides, they're alternating, and they're inside those parallel lines. So what's the other pair of them? I already heard from you, Major Cecilia. No, G and B are not alternate interior. Andrew? D and E, absolutely. D and E are alternate interior angles. Right, and that's all of them. Cecilia, remember what you said though, okay? Just hold it in your brain. If we're looking at alternate interior angles, if we're looking at C and F on opposite sides of that, what's this line called? Through two parallel lines? Ooh, for the win. As a reminder.
Ooh.
Transversal. A transversal is a line through two parallel lines. So C and F, we can get real fancy. They're on alternate sides of the transversal. What do we know about the measures of C and F? Looking at this. Say. Go ahead. Ooh, nope. C and F are not to the man. C and F are congruent. They are the same. Here, let's choose one reason why. Who can tell me, walk through some reasons why C and F are congruent? Duke.
Because 105 is the same as E, and E is the same as D, so then that would make...
Hold on, but you used alternate interior to say that E and D are the same. So 105 is the same as E because they're vertical. 105 is also the same as what? For what reason?
D.
Why is it the same as D? Austin? Cool. So we can use our first two definitions to prove our third definition. Right? So 105 and E are the same because of vertical angles. 105 and D are the same because of corresponding angles. So that definition, alternate interior, means E and D are also the same. Whew. Yeah. Okay. We're going to Cecilia for this next one. Next one.
I'm not gonna have any room.
Alternate exterior angles. Cecilia, what'd you say last time? G and D are alternate exterior angles. They are on the outside of those parallel lines, and they are on opposite sides of the transversal. Alternate exterior angles. Our last one.
That would also make 105 and A.
Yes. Yes, it would. But I don't like writing notes I haven't written the 105 because I don't want numbers on my letters here. Okay, last one. Same side interior. Hurt me too though. Same side interior. Already hurt me now, okay, didn't it? Oh, okay. What do you got? Yep. Yes. Gosh, I love it. C and E. These guys, C and E, are on the same side of the transversal, and they are on the inside of the parallel line. So C and E are same side interior. So what's my other Finn? D and F. Whew. Are also same side interior. Now, let's look at same side interior. Just looking at D and F, are they the same? No, but what are they?
Well, they are the same
Yeah.
in one way. In fact, they're on the same side.
So check it out.
Honestly, more on one way, but also both angles.
They equal up to 1.
Yep. So, same side interior are supplementary. They add up to 180 degrees. All of our other definitions were all just fancy words for saying these were pairs of congruent angles. Right? So those first four, vertical angles, corresponding angles, alternate interior, alternate exterior, all the same. Congruent angles. Only difference is same side interior gives us our supplementary angles. And that makes sense because looking at those 8 angles, right, looking at all 8 of those angles, you should have found, if you actually did your warm-up, that there were only 2 angles. You were either doing 105 or 75 for all of them, except for H over here. Okay. This idea here, though, this bottom one, this same side interior, that's the same thing that we have going on in our quadrilaterals, in our parallelogram. Right? You have 2 angles. If I extend my parallel lines, the other side is a transversal, and I have 2 angles that are same side interior. Those are also supplementary angles. I'm going to say that once. That was an A-level description, just so you know. Some of you guys who are going for the A, that's going to be something you gotta. Okay. All right. Questions, comments, concerns? We're okay?
She said she was saying it once. That was once.
I won't. I will say the description was something about how same side interior is connection to the adjacent angles of the parallelogram. How to explain that. Okay. I'm not going to talk about your homework because I already did. I did have a few of you tell me, of you 8, who said you didn't know how to do it, or you were absent on Wednesday, but you were here yesterday, and so sucks to be you. You should have looked. I don't know. When you're absent, it's your responsibility to figure out what you missed. And if you're here on a build day, I don't count that as you missing the math day. Like, if you're here, if you skipped Wednesday or you were absent and then you were here yesterday, I expect you to have your homework done. Like, it's not like, oh, I didn't have, like, it's not last math class because you had time. That's how I feel about it. You had time to get what you missed. You had time to ask about it. We see each other every day, right? Isn't that nice? Okay. So I'm not going to talk about that. You all are going to take your quiz now.
What?
It's in your quiz.
Great.
Matt, pick it up. Huh? No, you gotta take your group quiz. Twitty. Same thing we witnessed when we go outside, like yesterday. Some of you sometimes think you know, and then you come back with a wrong cut piece of wood.
She's like, bruh.
Or sometimes, I hear a lot when I'm walking by, which I love, people going, wait, are you sure? Did you check? Are you sure? Which is great. Just having that little bit of confidence. As we've seen, hopefully, I see it all the time at least, people who, especially in math class, think that they're really good at doing math, sometimes struggle a little bit and come back with weird stuff when we're outside. So just making sure that we can balance each other out. So you're going to have 10 minutes where you're working on your own, and then I'll give you 10 minutes to work as a team. Clear? So you'll get the chance to talk, but right now let your brain have its own space. Don't worry about anyone else's thoughts, and come up with your own solutions to these problems. On this number 8, I'm asking the angle the studs need to be cut at. Some people were like really upset about what angle I was talking about.
You're like, bruh.
Talking about the little angle that the studs need to be cut at. So
That's totally.
so I think at least one person from each table has worked on these walls in the back. So I'm just going to leave it out there. Or if you've never looked at a saw, I'll just say this. If you've never looked at the miter saw, and you go to try and cut like an 86-degree angle on the miter saw, you're going to be kind of disappointed. So that's all the other thing I'm going to say. Okay. So 10 minutes on your own, and then we'll give you time. I'm going to 10 minutes to make any corrections. I'm not going to grade the third paper again. Okay. So what I would advise is you tear them back apart, read your work, and then you'll re-staple after 5 minutes. Questions? Nope.
Which grade matters?
And quadrilaterals. And there are going to be several different ways that we are talking about. Really, it's about triangle and quadrilateral congruence and properties, but I'm not going to write all that out. So, triangles and quadrilaterals. To get us started, we are going to do an example. Whoa, what were my numbers? As an example, I want you to graph the quadrilateral AD. I want you to graph it, and I want you to label your points. As you guys get to writing these down, you'll notice all the numbers are positive, integers, being whole numbers. So you don't have to draw the full t-axis, you only need to draw the positive, the first quadrant of x and y. Right, so you only need to draw in the positive direction of x and y if that helps you out. But you'll make an x and a y axis, you'll put some numbers on there, plot your points, and label them so I know which one's A, which one's B. graph, or as you finish, go ahead and take a peek at your partner's paper. Make sure we didn't graph our points upside down, or if you need a quick reminder of like, hey, which one's X or which one's Y or what do I have to do again? So you can remind yourself of how to graph. Make sure we all have the same quadrilateral on our paper. Look pretty close to this. Also, if it doesn't, I'm showing you right now how I want your graph to look. If your graph doesn't look like that, maybe fix it a little. Notice that I have arrows on my axes. It's a small detail, but the sooner you start graphing correctly, the better. Small arrows on my axes, X and Y, and I've labeled some sort of scale. So I have some sort of scale on my axes. I just went by one, like I didn't have scale. I just went by, each space was one, and I label every other because I am lazy.
What if it's flipped? What if A sent C only sort of this one white out?
It should look like this. If it doesn't look like this, then something somewhere got flipped or we did something backwards. Okay, so make sure it looks like this. Again, because point A, 1, 6, ordered pair, X, comma, Y. That would be 1 and that would be 6. As a reminder. So again, hey, whoa. I know it's been some time since some of us have done some graphing. Okay, next cue, don't say it out loud. No saying out loud. In your brain, or maybe actually, let's better, right here on the side, I would like you to write what you think that shape is. Don't say anything, just write it. Write it down. It doesn't matter if you're right or wrong, just write it down. What do you think? You can't be wrong if I ask that. So I can't tell you that's not what you thought. Anyone feeling so bold as to be like, I know what shape that is? Andrew.
Rectangle.
All right, who else thinks rectangle? Cool. How do we know? Because we're moving into the theme of this semester, actually, is going to be proof. How do I know for sure, what would have to be true if that was a rectangle? What would have to be true if that was absolutely 100% positive a rectangle? Duke.
The measure of angles A, B, and all the angles have to be 90 degrees.
Cool. All the angles would have to be 90 degrees. Thank you for using the definition. Note, there are some other things that would be true, but by definition, these would all have to be 90-degree angles. Now, next question. How do I figure out and prove if those are 90-degree angles? How can I be for sure that I have 90-degree angles? Something that's special about rectangles that maybe we use in our foundation layout because maybe things are connected. What, Ethan? Are you 6? Oh, what'd you say? Diagonals, what about them? What about them, though? Yeah. Okay, if they're both equal to each other. So let's take a look.
But every line is diagonal.
Hold on. No. We don't have any diagonals drawn right now.
It is
No, within
diagonal.
the shape.
Honey,
Right.
no. It is, I'm talking, yeah, Sam, within the shape. So here, when I'm looking at this, within that shape, I want to know that is the diagonal as defined as the corner to corner within the shape. Yes, those lines are drawn diagonally, but they're the sides of the rectangle in this situation.
That's different.
Now you know what I mean. Okay, so this, DB, would need to be the same length as AC. My diagonals would need to be the same length. Now, here's what we're going to do. To calculate this length, how would I calculate the length of DB? Sam?
By looking at it as if it was,
Hey, be quiet.
looking at it as if AB and DA were the legs of a.
Shh. If you don't want to pay attention, how about this? Here's my offer. Leave school early. Go. If you're going to interrupt me, get out. Does anyone want to take the offer? You are going to get in more trouble if you interrupt me than if you just leave right now. I'm not kidding. I won't say anything, but I just need you to go away because we're trying to do some work. No one? It's a real offer. You are tempted? Okay, if you're agreeing, then just don't interrupt me. You'll get in much more trouble for interrupting me than for just leaving. Okay, what were you saying, Sam?
So if you use the lines AB and DA as the legs of a right triangle, you could then find DB as the hypotenuse.
Okay, yes and no. If I think about DB as, the hypotenuse of this right triangle, do you guys see what Sam's talking about?
Yeah.
The problem is, how long is AB? Don't you dare say 4.
5.
No.
Can we turn it into another triangle?
Right, so here's the deal, right? We can't use AB or DC. What we can use, though, if I'm talking about BD, I need to use the actual paper shapes on my graph paper. I need to turn this into a right triangle here. That's the right triangle that I'm talking about. To find out DB, I would use, as an actual right triangle right here, these lengths, 3 and 6. Okay. I would do the same thing for AC, right? I would make AC into its own right triangle, and I'm just going to go this way because I can. I'm going to make AC into a different, right triangle. I hate that. Oh, so sad. Okay. AC is going to turn into a different right triangle. What is happening, marker? Oh,
Slow it down.
oh, sad. Okay. So here's what I need. Half of your table will find the length of BD. This half, the right-ish half, or your left, whatever half of the table will find the length of BD. Other side of the table, find the length of AC, please. We need
Wait, what are we doing again?
finding the length of BD, Malachi fit. 6.7. Length of AC. Nobody. Because I didn't write those. Because I didn't write that one, or what? Should have been, it was 4 by 1, 2, 3, 4 by 5. 6.4. Are those the same?
No.
Is that a rectangle? No. How many of you wrote rectangle?
I did.
Yeah. I wrote parallelogram.
I didn't write any parallelogram.
If you wrote square, I have even bigger concerns, but that's okay. Not really, not really.
Oh, it's a.
So again, listen. It's certainly not a rectangle. The diagonals are not equal. Okay? It's not a rectangle because the diagonals are not equal. Now, again, this is our introduction, so I told you the theme of the semester being proof. A lot of times it's really tempting to be like, well, it looks like a rectangle, so let's call it a rectangle. Our studs look parallel, but are they really? We'll see when we put up the siding because we're going to have some issues. But that's okay. We'll fix them. Okay? That's that. Because I like you guys, it's better than period 3. I'm going to give you 7 minutes right now to start on your homework. That's on film? Oh, shoot. I'm telling you, for real, like, I'm not even lying. I'm not lying. They did not get time in class to finish homework, and if you guys would like to in any way try and keep your lead, I would use the 7 minutes wisely.